Good afternoon, ladies and gentlemen. Thanks for joining us in a discussion about security. Now, of course, I have to wonder when the schedulers decided to put security topic, which is not always the most exciting thing on the agenda, right after lunch. You get the snooze and the snooze. But hopefully we'll make this at least useful for you, which means conveying some information about how we practice security, giving you some background on what security means to us, and more importantly, how you can take advantage of the tools that we give you to secure your resources when running in AWS. Now, the interesting thing about security is, from my point of view anyway, it is not one thing, nor is there a situation where one is secure versus not being secure. This is a continuum, and more importantly, it's a situation where it means different things to different people. So as security practitioners, as security professionals, we have to find ways to meet the differing business goals of our individual components, as well as the requirements that we have levied on us by outsiders like regulators or contractual obligations we've got with other parties, et cetera. So doing so requires a variety of different tools and techniques, but I believe all of it requires a certain underpinning of skills, of capabilities, of practices, of procedures that together form the basis for successful security in the cloud. There are seats up here in the front for folks who are still coming in. If you're brave enough to sit in the front row, I don't have any water guns or anything like that, so nothing exciting. Now, our viewpoint on security, my viewpoint on security, is that it is both art and science. It is the art of finding that point of inflection where you balance your business needs to make data, information, et cetera, available to people, but also restricted to the point necessary to protect the interests of your customers. So this is a kind of a fun balancing act where we have to figure out what are the controls necessary so that I can do what my customers are asking, I can answer their requirements, but I can also keep things safe that have to be kept safe. And then the science portion of it is implementing controls which meet those business goals. At Amazon Web Services, security is our #1 priority. I mean, you heard this from Andy Jassy earlier, and there's a really good reason for that. Unlike a lot of different businesses or different companies out there, we don't have a physical good that we sell you. We don't send boxes through the post that have smiley faces on them and arrive at your door. We simply hold and retrieve, store, process, et cetera, your bits, your information. We're an entirely logical services provider. That means that that provision of services, the security of that provision of services, is the only thing that we have which establishes trust with you. So we have to get it right. If we don't get it right, we don't have a business. Okay, that's interesting. No pressure. But what it does mean is that we pay a lot of attention to this every single day. Now, a lot of people walk into the room, especially those who've really not dealt with Amazon Web Services that much, wondering, well, do I have to change the way I do business? Is this an entirely new model? Is this something that I've never seen before? And the important thing here is that no, not really. This is a circumstance where you will see many of the same controls that you've seen before. You'll see many of the same processes and procedures that you might have in your own on-premise environment, or you might want to have in your own premise environment if you had the resources to do it. And more importantly, there are only so many ways that you can implement certain things like video surveillance. And there's no real rocket science involved in that process. Security is a topic which engenders a lot of interest by a lot of different people. And it's something where it's not enough to say, trust us. Security is an environment where there has to be a validation. Now, this is sort of like the Reagan-era trust but verify détente. It's the same thing in the security world where we believe that it's important for you to be able to rely on a third party's evaluation of our security processes and procedures when you make your decisions about where to put your information, your data. So we've got a lot of different people looking at how we practice security, and that produces a really interesting result. We build our services uniformly across the globe. That means that the services that we provide in the US are secured exactly the same way as the ones in Sao Paulo, exactly the same way as the ones in Australia. We don't do anything differently. The uniformity of that application of security means that we have to build to one bar, to one expectation level. All right, what does that mean in reality? It means that we have to build to the highest bar that any of our customers set for us. So when we've got extremely demanding customers who require us to do all sorts of interesting things from a security perspective in terms of continuous monitoring, et cetera, it means that the guy in his dorm room in college using our free tier gets to take advantage of that same security that someone who used to have to pay hundreds of millions of dollars to do every year. That's really empowering for small businesses. It's really empowering for individual developers who are just starting up their online game, for example. And it's something for us that's a fundamental part of our business, principally because security controls are things that must be done right every time, all the time. So I believe really strongly in making those security controls simple. Simplicity in security controls is really important because that's the only way one can reliably validate if they're being implemented and repeatably implement them across the planet. Just as a note here, across the world, we implement about 730-ish different controls focused around security. And we'll talk a little bit about how we express those to our customers in a moment. Now, the fun part about being in this position is that the customers tell us that as a result of being on the AWS infrastructure, they're often in a better place than they are on-premise from a security perspective. And that's a really, really powerful statement for me. It means we are helping our customers serve their customers better. Tom Soderstrom, CTO of NASA JPL, gave me this statement during a meeting, and I said, please, can I stick that on a slide? That's really cool. And he agreed, because he was saying that he is better off running an AWS, and it's principally because of those three things that are on the slide. He's got better visibility into what's going on in his infrastructure. Because he has better visibility, he can audit it better. And because he knows what's there, he can control it better because we give him resources designed specifically to do that. We'll talk in a moment about what those resources are and how you implement them. Visibility is the first part of that process. The picture on the screen may be familiar to some people who have operated a data center. That is not a particularly visible environment, and that's reflective of most of our customers who come in the door. Why is that? Well, because things accrete over time. They build up. And in conversations with security professionals, most CIOs in a lot of places, when they're talking about what changes when I move into the AWS cloud, I'll say, well, for one, you're going to know what you have. Well, I take an inventory of everything that's on my network and my systems. Great. You're 10 steps ahead of a lot of people out there. How often do you do it? Once a year. Oh, congratulations. That's still better than a lot of people. But what does it mean on once a year plus 1 day? Things are different. Things have changed. And how do you know what's changed during that time? And knowing what you have is the first step in knowing how to protect it. The other problem you've got in this kind of scenario is when you walk into a data center and you walk up to a rack and say, what's that? And the person who runs the data center says, ooh, that was installed by Tom 3 years ago and he's gone. So we really don't know. And we're like, whoa, why don't you get rid of it then? Oh, I'm not going to unplug that. I don't know what it does. And that's a serious problem. You don't want to break the business, but at the same time, you've just said it's okay to have this thing that I've got no idea what it does sitting there, connected to your network functioning. That doesn't happen in the AWS world. Why? Because every single interaction you take with us is via an API. Everything is driven by instructions to a computer system. What does that mean? It means that there is a record of every action that's taken. So you know who did what with your systems, who attached them to a network, who changed a firewall log rule, who made the connection between this system and that system possible over a network. Furthermore, you can audit that information whenever you want. Literally. Tom Soderstrom, the guy we talked about before, NASA JPL, his security team takes a look at their infrastructure running on AWS every few minutes. Drastic difference from a situation where they were before, where they were not knowing what was going on in infrastructure over time. The net result is that you're in a lot better place when you programmatically control all of your infrastructure. And programmatic control is available to everybody on AWS. In fact, it is the only way that you interact with us. So this is a situation that everybody gets to take advantage of. Let's take the next step in here. Auditability. AWS is a global company. During the keynote, you heard from a lot of people around the planet, not even speaking English, who are telling you about what they run on AWS. Well, guess what? We as humans speak different languages around the world. We as humans also have different requirements around the world. We have different compliance regimes that we must meet in order to conduct business in different places. Privacy regulations are different. Regulations about the movement of data from point A to point B are different. So AWS as a global organization must speak the language of the local customer. And that local customer could be geographically based, but it also could be different based on industry vertical. So we have a lot of healthcare customers who require us to be compliant with HIPAA regulations in the US. We've got federal government customers who require that we meet FISMA in the US. We've got UK government customers who require that we meet their particular standards for data protection and availability, et cetera. The net result is that we have a series of certifications that are available to customers around the world, and it's the way that the customer can look at how we practice security and get their own judgment about whether we do it sufficiently to meet their business goals. These particular evaluations are done by third parties, outsiders. In our case, it's Ernst & Young, who come in and they test whether we're doing what we say we're doing. So literally, if our control is that in United States data centers, we keep CCTV records for 90 days for all cameras, they will go in and say, for July 3rd, 2013, pull camera 67 from 0000 to 0300 hours. And we have to go produce it. And they inspect it and make sure that we actually do it. And they go through all 700 odd controls that we've got and do that kind of spot check. So they're inspecting to ensure that we actually do what we say we're doing. Realistically, that's the only way that we can convey that information to customers. Occasionally we have conversations with customers, they say, I want to come in and do a data center on it. Like, yeah, I appreciate the desire. This is the way we can accomplish that for you. Realistically speaking, we've got hundreds and hundreds and hundreds of thousands of customers. We can't have them all coming through our data centers. It's just not practical. More importantly, I really would hate for you to be the guy who trips and falls and takes down somebody else. So from a liability perspective, this is realistically the only way to manage that. The benefit of this, of course, is we have a commonly understood set of results. What that means is lots of people can take advantage of the work done by a few. The net result of that and the interaction with customers is that people are starting to realize that this is not just NASA JPL saying they can be better off when they're in a cloud environment than they can on their on-prem. This is a lot of people saying the same thing. And one of the really fun parts of my job is seeing that revelation, that sort of flashbulb moment on somebody's face when they say, whoa, I can do that in the AWS cloud, and I couldn't in my own environment. And it's something that we want to continue the process of working through security controls, security implementations that raise the bar for everybody out there. Visibility. Visibility is all about knowing who did what, where, when, how. The why portion, you have to intuit because we can't get inside the heads of humans. But the important point here is that when you're using AWS, your actions produce logs. Now, lots of us have security management platforms out there that produce logs. Lots and lots of logs. Logs, number one, are a pain in the neck to store. Well, the nice news is that Amazon S3 and Glacier make that pretty easy to do. Those of you who are security practitioners in the audience, I'm sure you don't want to be in the position where something goes bump in the night, and one of your managers comes up and says, do we have a log that shows what happened when this occurred? Yes, we do. Here it is. Why didn't you look at it and recognize this a while ago? Ooh. So keeping logs is a useful and necessary step, but you got to use them. You got to analyze them. You got to gain information and intelligence from them. And that's where it gets fun, operating in the cloud. Because you can store the logs easily, cheaply, there's no excuse not to keep them. Because you've got instantly available large clusters of machines, you can do analytics that were never possible when you can only do it on premise for a few. For example, my team does analytics on the behavior of our employees every morning. We take the actions that all of our system administrators take when they're in contact with customer data and they execute a privileged command, and we analyze them to see if they're consistent with the behavior of an employee who's in the team that that person is assigned to. How do we do that? We use large elastic MapReduce clusters, Hadoop clusters, every morning, tens of thousands of machines that crunch through a whole bunch of data on the behavior of our employees very rapidly. And what happens when we're done crunching them? We turn the machines off. That's the kind of power you got in a programmatically driven environment. Spin up a lot of stuff, do it real quickly, then shut it down. So analytics starts with getting data. Getting data starts with knowing what happened on your network. AWS CloudTrail is our service that we announced relatively recently that allows you to keep records of API calls. What does that mean? It means when you interact with us, you interact with our computers via an API, whether it's through the console or whether it's using a third-party SDK, for example. And each of those interactions, whether it's starting a virtual machine or connecting a network interface or changing a firewall rule, creates a record. We store those in CloudTrail and deliver those log files to your S3 bucket. This allows you to know who used your credentials on AWS to take what actions with your resources. That's wonderful. Security analysis totally makes sense. Interesting byproduct that we didn't expect when we launched this is operational benefit too. We found when talking to several of our large private beta customers that when they started seeing performance problems in their AWS resources, they found the easiest thing to do to start troubleshooting the problem was to look at the CloudTrail logs and say which one of their employees changed something right before the performance impact occurred. And they're like, oh, wow, Tom just shut that firewall port off. No wonder traffic's not flowing from point A to point B. Unintended side benefit of a security process. Hey, cool, we'll take that, it works. This kind of information, though, is critically important in the compliance process. Compliance requires that we have logs that identify when certain kinds of actions are taken and by whom. So this is a very necessary part of some people's ability to meet compliance regimes. How's the process work? Really straightforward. You make an API call to us. We record where that came from, the IP address, the credentials that were used, and the action that was taken. Within about 15 minutes, it's usually a lot less than that, but that's the number we give you as an expectation. That log is delivered to an S3 bucket that you designate within about 5 minutes of our processing of it. Now, the really good thing here is that we don't leave you at that point. There are a lot of different partners, and I'll talk about them in a moment, who can help you process that log information and turn it into something that's beneficial, that's useful, that you can take actions on. Now, defense in depth. This is a term that's thrown around a lot, but it's something that it's sort of really poignant for me personally, but it's something that AWS focuses a lot on. When we have conversations with people about security, they'll often say, well, you know, what's the sort of the big roadmap for you guys down the road? What are you going to be focusing on more and more and more? And the thing that I would say most is driving the perimeter down on things. For a long time, the IT industry has been focused on security around setting up sort of borders around things. It started off with firewalls at the edge of your network, and then maybe a web application firewall a little closer in. But if we can learn from history, that didn't especially work super well for human habitation. It used to be that people would live inside a town that had a big old wall around it. The problem is that when the bad guys get inside the wall, there's not a lot to stop them. They can pretty much run amok. So what we've tried to do is to drive that perimeter down to the smallest possible object. That means that you can, using our access control languages, write rules that say things like, for this S3 object, the only person who can access it is Fred, and he may only do so between the hours of 9 a.m. and 5 p.m., and when he's on the corporate network, and when he has a hardware authenticator in his hand. That's a pretty powerful set of restrictions to be able to put on an object of data. Now, the important part about S3, of course, is you don't have to be that restrictive. You can say, every human on the internet can read this data. Okay, you can do either one. You've got that entire panoply of options available to you for access control there. Speaking of access control, a commonly asked question from customers is, so what can your staff access of my stuff? And the answer there is that our staff do not have logical access to customer data. So as an example, a virtual machine that you're running, we do not have access to the OS layer on that with credential rights, meaning I don't have a root credential that I can log into your Linux box with. I don't have the administrator password, presuming you followed the rules and changed it, on the Windows machine that you're running on AWS. We think it's really important that there's that clear delineation between what the customer owns and what the customer controls and what we have access to. Now, how do we do that? A lot of this is detailed, by the way, in our security white paper, which is off of our security website. I should have a link on the screen there, but I don't. aws.amazon.com/security. And we go into detail about how we affect that. So if you're interested in learning more, we'll give you that again later on. Staff vetting is the first bullet on this. And that's about how do we select Amazonians. Yes, an Amazonian is someone who works at Amazon. The process of selection obviously involves an evaluation of whether the person can be trusted to be in contact with customer information. And we do that through a series of staff vettings. And a staff vetting consists of our examination of things that we find are probative as to the person's trustworthiness. For instance, do they have a criminal record which indicates something other than parking tickets, for example? Do they have a situation where they got expelled from school for hacking into a particular machine on a school network? Have they lied somewhere in the process of giving us their background? Now, the great thing about staff vetting is that it's not uniform across the planet because the rules are different around the world. We apply the highest standard that's available in the jurisdictions in which we operate. So in the US, I can look at your financial history, I can look at your criminal record, I can look at your school background, your previous employers, et cetera. Whereas in Ireland, for example, I'm not permitted by law to look at your criminal history. The net result is we've got a picture in time of how trustworthy is that individual. A picture in time. So the real question is what happens after that person arrives at the door? And the answer is we revet staff on a basis consistent with their access to customer data. So if you have access to customer information, you're, for instance, on our identity team. You control the very credentials that you use to access AWS. I'm going to reevaluate you on a much, much more frequent basis than I might reevaluate a salesperson, for example, who has no access to customer information whatsoever. Staff access also means how do we control the way our people use computer networks to do their job. Now, the important part about the way we function at AWS, Amazon as a whole, in fact, is we operate under the principle of least privilege. Least privilege means that I'm only going to grant you the rights to do things on our systems and networks that are necessary for you to do your particular job. And we enforce that programmatically across the operations. Programmatically is the key point. And the way we do that is through a series of permissions management systems that link a human to a job function. So let's say that Alan here is on the EC2 team, and he's a software development engineer. His manager says, yes, Alan must be granted access to this set of machines in order to do his job. So the permissions management system adds him to the appropriate group. He can access those machines. Now, every 90 days, Alan's manager has to go back in and say, yes, he still needs access to those machines to do his job. If the manager doesn't do that, the system automatically revokes Alan's access. It is a fail-safe. Furthermore, if Alan moves within the company, say he transfers to the S3 team, our personnel management system changes his cost center. The permissions management system notices that his cost center has changed, and it automatically revokes his prior access. So the point there is restrict the access to those machines that are absolutely necessary for the person to do their job. Going down the road, let's say he's authorized to access the set of machines on the EC2 network. How does he do that? Well, in a simple environment, I open up my laptop and I log in to that machine. The problem with that is twofold. One is you're using a device which contains a lot of opportunity for someone to do unpleasant things with it. So what do I mean by that? We know that there are nation states out there who make a practice of collecting valid username and password pairs and using them to exploit access to information. So how do we prevent that from being a problem in AWS? Two ways. One, the username and password that you use to log into your corporate desktop machine, the laptop that I carry in my backpack, does not work at all on the AWS infrastructure. It is not the same authentication. We use a separate auth stack on EC2, for example. In EC2, I can't authorize myself or authenticate to a system with my username and password. I have a separate identity, and that identity is represented by a certificate, not a username and password pair. So for example, if Alan wants to connect up to the EC2 network to do work, he goes from his corporate laptop and authenticates himself to a Bastion host. A Bastion host is a system whose job it is to enforce the second authorization and authentication point, but it also gives us a location where we can watch everything Alan does when he's in contact with customer data. We can record everything that happens when he is in contact with customer information. That allows us as security professionals to assure ourselves that the things he's doing on that network are appropriate for his job. And furthermore, we have the option of requiring Alan to use a hardware token, a smart card, to do that authentication, as opposed to using a certificate stored on another machine in soft format. So we talked about controlling people's access, watching what they do on our network. We talk about need to know. This applies to physical things as well as logical things. So physical things, I mean data centers, places that physically house your information. If you ask an Amazonian where our data centers are, they'll be able to tell you Northern Virginia, Dublin, Sydney, Australia, etc. What they won't be able to tell you as a general rule is where exactly in those locations. Why is that? They don't need the address to do their job. If they work there, they obviously do. But as a general rule, we follow that across the company. If you don't need the information to do your job, you don't get it. Now, obviously, security through obscurity is not sufficient in and of itself, but minimizing the number of humans who know where your stuff is stored physically is the first step in a reasonable series of controls to prevent unauthorized access. Now, let's say I'm authorized to access those data centers. Can I use my corporate badge, the one I use to get into our office building? No. We operate a second, separate card management system for the data centers. Why? To prevent errors. Remember what I talked about earlier about simplicity in controls? It doesn't get much more simple than this one only works on corporate, this one works on data centers. It prevents errors in provisioning. So a security operator can't accidentally provision you who might be a software development engineer sitting in an office building access to a data center. Preventing errors through simple control implementation. Talk briefly about change management. Change management is a question that comes up in a lot of conversations with customers about situations where they want to understand, when am I going to experience downtime? It's not strictly security related, but it's a sort of an interesting piece of the puzzle that we deal with every day. An important note here, you'll note that we don't have maintenance windows on our facilities. We don't say this is going to be out of service on Sunday from 1 a.m. to 5 a.m. We have to operate in a continuous operation model because we are a global company. That's something Amazon figured out a long time ago. It was just necessary to do the job. So what does that mean in terms of change management? Change management in our organization is focused around continuous rollout of new software features. So to quote Werner Vogels, our CTO, we roll out a new version of software in Amazon every 16 seconds. 16 seconds. Now, some people say, well, I'm going to do patches on Tuesday. Every 16 seconds. What does that mean? We have to be really good at rigorous automated software rollouts. So in function, what does that mean? It means that there are a series of well-defined processes, well-orchestrated procedures that are enforced by a change management control system. So I'm a software development engineer. I'm working on the S3 team. I'm working on the S3 web servers. I write a new version of a particular piece of software that I'm responsible for, and I want to put it into production. How do I do that? Well, I've done the work on my laptop. It's uploaded to a server that manages software centrally. It's checked in. It goes through a code review process by my peers who say, yes, what you did was sane and you're not about to blow everything up. It then goes into the first set of test environments. An alpha test proceeds to a beta test. A beta test runs a series of things like, does it perform the functions we expect? Does it perform with the load that we expect? Can it process the number of transactions per second, et cetera? There are a series of security controls that we also apply at that point to see that if it's enforcing the access control languages appropriately. If the software passes that beta test, what happens next is it's promoted to a gamma environment. A gamma environment is a small version of the real thing. So if the real environment has tens of thousands of machines in it, the gamma environment may have 1,000. But it's the same machines performing the same functions. Another set of tests go on there. If that works, we roll out in what's called a one-box rollout. A one-box rollout means literally that my new software is placed on one system in one availability zone in one region around the world, and it's left there to bake to make sure that nothing happens inappropriately. If it passes that bake-in test, it can be rolled out to all of the machines in one availability zone of one region. The point here is to never affect multiple AZs at the same time, so that customers who want to design for high availability or high durability can do so. Data destruction. This is the opposite of keeping your data safe. This is when you tell us to get rid of something, making sure we get rid of it. Again, back to simplicity and controls. I would ask the question, if there are too many people in the room, what happens when you have old computers or hard drives in your environment? Where do they go? When we ask people that question, we often get a look of, it's taken out the back door, and it stops at that. Well, for our standpoint, we have to have a really simple rule here that all of our data techs can follow. No hard drive may leave our facilities intact, period. That means that they don't have to think about, was this ever installed in a system? Did it contain customer data at some point? No, make it easy. No hard drive leaves our facilities intact, period. So what do we do? Well, this is actually kind of fun. For magnetic media spinning disks, we degauss them using an NSA-approved degausser. Don't stand around those if you have a pacemaker. And then the disks are physically destroyed. That means either a hydraulic press that punches a bunch of holes through them, or they're chipped into pieces that are about that big. The net result of that is a recycler gets to take a bunch of metal away. For solid-state disks, obviously degaussing doesn't do anything to them, since there's no magnetic media in there to destroy. So in that case, we have to chip them into very, very small pieces that are about that, well, you can't see, a couple millimeters by a couple millimeters. Has to be smaller than 1/4 the size of the smallest memory module on the device. What that results in is a really easy thing for our security guards to enforce. When they see one of our humans coming out of a data center, they have to go through magnetometers. If it goes off, why? Well, a hard drive, that's a problem. We can stop them. It's also easy for them to say, this is a bag of dust. It can leave, because it represents the shred results of all of those machines. Shared responsibility. Remember in the beginning I talked about things that we have to do on behalf of everybody, and things where we give customers choice in how they implement security controls. This is all about us taking over the undifferentiated heavy lifting portion, the muck, that underlies everybody's IT systems. Everybody who's out there has had the headache of dealing with power before, and networking, and the physical buildings, and did the roof leak, and did the security guards show up for work, and all those things that are pain, that are processes, that are parts of running an IT infrastructure. Well, we do all of those on people's behalf, and that's actually one of the reasons that AWS started, is Amazon realized we're really, really good at doing that on a very large scale, and that's an area of work that many people don't find differentiates their business. It really makes no difference when you're a bank how well your IT department connects network cabling necessarily. You just need it done to a certain standard. So we take on that heavy lifting for people. The customer, on the other hand, gets to choose a bunch of implementations. They get to choose which operating system they use, what the firewall rules are that they configure, which applications they permit to be installed on their machines, et cetera. Now, there are some choices that we force every customer to make, and one of them is listed on there as security groups. These are the firewalls that are on every virtual machine in our infrastructure. Every VM that you spin up in Amazon has a firewall in the hypervisor itself, and that firewall starts off default closed. So you have to make a conscious decision to open that to the outside world. Again, this is about helping everybody make good choices on containerization, perimeterization of security. Your data stays where you put it. We have 10 regions around the world. There are only 9 up here, unfortunately. But those are boxes into which customers choose to put their data, and we keep it there, absent them telling us to move it somewhere else. For some of our customers, particularly those who are subject to privacy regulations around the world, this is critically important. We don't do global load balancing. We don't move your data back and forth across the planet on your behalf unless you tell us to. So within a region, that's the big white boxes on the screen, you have availability zones. Availability zones are the smaller boxes. Those are the customer-facing equivalent of a data center. And I say equivalent of because in some of our regions, one availability zone may be made up of several physical buildings because the region is so large. But the point there is to give customers the necessary pieces to make good decisions about the durability and availability of their data. For some of our services, like Amazon S3, when you hand us an object, we automatically replicate it across a whole region so that it's durable even if one of our data centers gets hit by a meteor. For other things, you get to choose where you store your data. So let's say you spin up a database in relational database system, RDS. If it's a test dev box, you say, you know what, to minimize cost, I'm just going to spin up one. It's going to be in one availability zone. I don't care if it goes away, if the building burns down. Whereas you may make a decision that's different about a different database saying, this is my production database. If this goes down, my company stops working. In that case, you may decide to put replicas across 3 availability zones in a region, as well as snapshot it, move that snapshot to a different region. So the point here is to give you the tools necessary to make decisions that are consistent with the way you want your business to function. And part of the decision-making process involves whether you operate in a virtual private cloud or not. And Andy brought this up in his keynote. Amazon Virtual Private Cloud is your way to carve off a piece of our infrastructure and treat it as your own. A little bit of history here. I owned the team that built VPC initially. The initial customer story and every development and effort at Amazon starts with a customer story and a customer request, was from a financial institution in New York City. They came to us and said, we really love this EC2 thing that you've got. I've got 9 data centers. I want to close one of them. The problem is I don't want to change the way I do business. I don't want to change the enforcement policies I have on my networks. I don't want to change the tools that I use to manage the things. They said they didn't even want to change the IP space that they were using because they were used to doing things a certain way and they had a set of procedures that they were comfortable with. Okay. So what we created was a way, literally, that the customer can come in and say, I want this box called a VPC on your infrastructure, and I want it to be all mine. I want to lay out a series of networks in there where I design the networks. I design what IP addresses are assigned to them. I get to define what firewall rules are in place in between those subnets. I design what the routing is off of there. You can even bring your own IP space to Amazon VPC, so treat it truly like your own network. Now, some funny people out there say, well, I can put Amazon's IP space into a VPC. Yes, you can, and it's not going to break anything. You know, go ahead and use our IP space if you want. It's not going to be routable in the outside world, but you can do it. The net result here is that it gives customers a tremendous ability to reconstruct the security enforcement environments that they're used to on their premise environment in the cloud, so you don't have to change the way you do things. No discussion about control would be complete without a discussion about encryption. First note, encryption does not solve all problems. Encryption is a useful tool for controlling access to information. Some customers choose encryption because they want to, because they think it's the best way to protect their information. We've got a lot of ways that we help them do that. Some customers choose it because they have a contractual obligation to do so. They have a relationship with another company. That company says there's a liability limit on what I can do with this data sharing with you, and to protect me from liability, you have to implement the following types of encryption. Some customers choose to do it because the law says they have to. They're regulated for some reason. So it's important that we give them a selection, an option set, to use crypto successfully on AWS. The important point here, though, is that there is a series of options that customers can choose. Customers can choose to have us do all the crypto for them. If you want to, and we do suggest this for any customer, it's free. Enable server-side encryption in Amazon S3. That way, whatever object that you put into Amazon S3, it's encrypted when it's sitting on disk. Why do that? Well, what if something goes wrong? Access to that disk is gained by somebody who shouldn't have access to it. If the data is encrypted when it's at rest on that disk, it protects your information. So use the crypto options we give you there. Some are enabled by us, but the customer gets to choose what the key material is that they use. So for example, I can use Oracle Transparent Data Encryption, encrypt my entire Oracle database using keys that I provide on AWS. Some customers choose to go the next step and they use crypto where they control it completely on their own premise. They run the key management infrastructure in their own data centers, and they store all the data up on AWS. So we've got the entire spectrum available of encryption solutions for them. We talked earlier about granularity and control and pushing that perimeter down, shrinking it around there. The important thing here is that we give you the tools that are necessary for you to make those decisions about shrinking perimeters, about automating checks, about doing fine-grained access control for your employees, like preventing people from accessing certain pieces of data unless they're the designated data control officer or something like that. Those are all available to every single customer on AWS. And they're available, in most cases, without additional charge. So it's something we strongly encourage everybody to take advantage of. You know, there are tools there that make your life easier in terms of preventing problems. And a little bit of effort ahead of time, following the best practices, for example, will prevent a lot of headache down the road when something happens. Cloud HSM. Cloud HSM is our service to provide customers with the way to generate, store, and use cryptographic keys on an AWS network where our staff does not have access to the crypto keys. Let me repeat that. Our staff does not have access to the crypto keys. So if a government comes in with an order and says, you must produce the crypto keys used by Alan, and he's using Cloud HSM, I can say, sorry, can't do it. You're out of luck. This is a service that we designed at the request of several of our European customers. It uses SafeNet Luna SAs, which are hardware security. Oops, can we go back one, please? Thank you. SafeNet Luna SAs as the HSM devices. And HSM, by the way, a hardware security module, is a physical piece of gear that generates cryptographic keys inside of an environment that is tamper-evident and tamper-reactive, which means that if one of our people comes and tries to physically open the box to gain access to the chips that are within it, it zeroizes the material that's in there. It literally wipes it out. The nice thing is that these are independently validated devices. You don't have to trust us that we're processing the information properly here. The crypto that's on them is FIPS 140-2 compliant, and the devices themselves have software that's EAL4+ certified, which means independent laboratories have looked at the software implementations and said, yes, it was done properly. The great thing here is that customers who use HSMs on their own premise can integrate those directly with Cloud HSM if they use the same type. If you're already using a SafeNet Luna SA on-prem, you can link it directly to the Cloud HSM service, so you can back up keys back and forth. So some customers, their primary operations are on AWS, but they want to have a copy in their own facilities just in case. It's an easy way for them to move those keys back and forth securely. Single sign-on federation. When you talk to people about identity management, one of the concerns that they have is, I don't want to have to maintain two sets of identities. I've already got this AD stack that's running on-prem right now in my own environment. Can I use it to run AWS too? The answer is yes, you can. So you can link Active Directory, anything that talks SAML 2.0, just about everything, up to Amazon and manage your IAM user sets on Amazon. What that means is that you can practically implement controls that say things like, when we terminate people in our company and we lock their accounts in AD, it also locks them out of AWS. And for some people, that's an important control to be able to have. The nice thing is it also gives you a way for people to sign into the console very easily. You can use your own credentials and your on-premise directory infrastructure to authenticate to our console, so you don't have to have a separate set of login credentials. And DynamoDB, which is our NoSQL database service, also supports very fine-grained access control, which means that you can do things like say, in this entire set of data, this table, this item, or even this attribute within an item, only people who are in this particular group can access it, or only people in this group can put things into the database versus read things in the database. So you can have people who are authorized only to place data there, but never to get data out. And in the converse, you can have the authority for some of your staff to read data to their heart's content, to analyze information and gain new knowledge, but they can't delete anything. And that's important to comply with some regulatory regimes, which require that only a designated individual delete data, especially in the financial services world. More new security features. This is the fun part of the conversation for me. Elastic load balancing. Andy talked about ELB. ELB is our load balancers that sit in front of web servers or application servers, et cetera. Several of our customers, in the wake of some of the more interesting Snowden disclosures, asked us for ways that they could help protect their own customers' data transmissions back and forth to us. And one of the ways you can do that is perfect forward secrecy. Perfect forward secrecy is a crypto implementation where even if a government shows up and asks me for a copy of one half of your key pair, after the transmission takes place, they can't decrypt it. This is not something you have to trust us about. It's widely described. We use commonly available libraries to do it, so you know exactly how it takes place. As part of that, there is also a concern in a lot of places about SSL implementations. There have been a lot of attacks on SSL recently. You've probably heard of Beast and some others like that. So people are focused a lot on which cipher suites they should use and which SSL protocols, whether you use TLS 1.2 or 1.0 or whatever. So we have given customers the ability on Elastic Load Balancer to enforce server-side preferences, meaning you can say, the only transmissions that I permit off of this server are using a specific set of protocols or a specific set of cipher suites. For some customers, that's just good security practice. For other customers, US federal customers, for example, they must, by rule, only use specific ciphers to do their business. And predefined security policies is about making it easy for customers to make good decisions. A lot of customers came to us and said, yeah, this Beast attack thing got a lot of news, but I don't know what to do about it. Can you please just give me a best practice template when I'm running an ELB that is kept up to date? So that's what we've done. With predefined policies, we give you what we believe the best practice is for implementation of SSL or TLS on your Elastic Load Balancers, and we are keeping it up to date. So that as new things happen on the internet, all you have to do is decide to adopt our new policy, and you'll get the same benefit of protection. The important thing there, again, though, is you decide to implement it. You may be supporting a bunch of really unusual old browsers on devices that you can't upgrade. So moving to new protocols may break them, so you may not want to shift. The point there is to give you the choice to do it if you want to. We've talked throughout this prezo a lot about the integrated permissions, being able to say who can start and stop EC2 instances, who can launch databases and store things in them, et cetera. All of the services that you see on the left-hand corner and the bottom of the screen there support very fine-grained access controls. So I suggest if you have an option, take a look at those. A recurring theme that you're probably tired of hearing, but I'm going to say it again, is we minimize our staff's access to information as a part of the way we do business. I think everybody should do the same thing. You never know when someone's going to have a bad day and decide that they want to do something inappropriate. So protect yourselves by using the tools that are available and minimize the access of humans to information. The right side of this picture is a little interesting. It's about AWS Marketplace. You heard about that from Andy a little bit earlier today. The important thing from a security perspective here is, though, a lot of customers were saying, look, I want to be able to use the same thing that I use on-premise, the same device, the same appliance, in the cloud. Well, we've had that for a while. The ones you see on the bottom right here from Check Point or Cisco or Citrix or Riverbend, et cetera, have been available in AWS. But we wanted to make it even easier for customers to use them. So if you're running in VPC, literally you can do one-click launches now of a Check Point firewall or a Sophos UTM. You can say, put it into this VPC on this subnet, and we take care of all the configuration garbage behind the scenes for you. Make it super simple to run these devices. Why? Because it's a good idea. Customers want to protect themselves. It's up to us to give them the necessary tools so they can do so. And with that, thanks for your attention. Thanks for your time. I'll be in the back for about 8 minutes if people want to chat a little bit. Thanks.